Hello, everyone. Let us try to understand the projectile motion, the basics of projectile motion using a simulation. So this is a pHet interactive simulation in which you can see one cannon, and this is the button allows us to fire the cannonball. And this is eraser, and this is the initial speed. By default, it is showing me 18 meter per second is initial speed and 80 degrees. And this is some target 15 meters. So I'm not sure where it falls, but by default, it's just showing me 15 meters. Now let us try to understand like how we see like what distance or what horizontal distance would it reach the ground after being fired. Okay. So let's try taking the equations of motion. So as we know, this is a two-dimensional motion. We have to resolve this into two kinds of displacements. One is along x-axis, one is along y-axis. So our target is to find out horizontally how much distance would it cover, correct? So how much distance horizontally would it cover? Let us imagine the distance as x. If we take x with the formula s is equal to ut plus 1 by 2 at squared, we write x is equal to uxt plus 1 by 2 axt squared. But in the oblique projection, there is no acceleration along x direction. The acceleration is along only y direction, which is acceleration due to gravity. This is an important point. So obviously, the second part of this equation would become zero, and ux meaning the horizontal component of velocity, which is u cos theta times t. Okay, let us try to figure out, would this be enough for us to find out the horizontal distance? Look at this. Do we have everything enough to find out the horizontal distance? U, we have initial speed 18, angle we have 80 degrees, cos 80, but we are stuck with t. I do not know what is t. So what do you do? Imagine that this projectile has taken from here to here. First, my target is to find out time here. So for that, I will take vertical displacement, because by the moment the projectile starts from here and ends up here, my vertical displacement would be zero. So I'm trying vertical displacement is zero. So y is equal to uyt minus half plus 1 by 2 ayt squared. With the help of this, let me figure out the time and then go back here and substitute what is the horizontal distance. Now, as we know, vertical displacement is zero once it lands on the ground. Uy would be u sine theta t, and this is negative g because it is along the negative y direction. And u sine theta t is equal to half gt squared. Now, time gets cancelled. You can say t as 2u sine theta by g. Now, what do? You have to figure out what is 2u sine theta. So 2 times initial velocity is given as 18 in the simulation, and angle is sine 80 degrees over 9.8. If I use calculator and find out this, I would get 2 times 18 times sine 80 over 9.8 as 3.617 seconds. All right. Now let me go back here and write x as u as 18 cos 80 degrees times time, which is 3.617. So when we put these values in the calculator, 18 cos 80 times 3.617 would give me 11.3055. So I'm approximately taking it as 11.3. That means this particular projectile will land at 11.3 meters. Now let me try whether it gives you the correct answer or not. I'm clearing my drawings now. Chalo, let us fire this now. Let me just bring to the distance of 11.3 something. This is what I got. Yeah. Now I'm firing it. Look at that. Yes, 3 stars. So exactly 11.3. It is matching with my answer. That is 11.3.